Hello, in the name of God, the compassionate, the merciful. Thanks everyone. Today I want to present a SAT-based analogy evaluation framework for Persian word embeddings. This is a work that we have done with Dr. Mehrnoush Shamsfard and I, Ehsan Mahmoudi. I am here to present the work that we've done together. Okay, the word embeddings, they are the de facto base for every NLP application today. And we know that why they are important is because quality of embeddings will significantly impact the downstream application that we want to use. Normally, the embeddings are used as tools to encode the language artifacts into vectors, and the vectors will dive into some pipeline of deep neural networks to do whatever application that is out there. So basically, the first and what we can say one of the most significant steps of every NLP application pipeline is to extract the word embedding and find the best model to fit into our application. Okay, so as we talked about the importance of the word embeddings, what is going to be important is the evaluating models. Evaluations of the models can be done in two ways, intrinsic and extrinsic. So what are they? So intrinsic methods are the ones that look at a word embedding by themselves, and they are not looking at the whole pipeline. We know that ideally, if we had like unlimited processing power and unlimited computational power, we could have used evaluation, extrinsic type of evaluations. It means we uh, plug in different models on start of our any pipeline that we have and choose the best model based on the final outcome of our full pipeline. But anyway, we know that this is not computationally sound and possible at the moment. So we have to find some ways that evaluate the embedding models based on themselves. So we have separate pipelines of training the embedding model and pipeline of whatever application pipeline that we have. So historically, when the word embedding models were proposed, different types of intrinsic evaluations were proposed. For example, we know that by the Mikolov articles, they introduced the word analogy, categorization, word similarity type of evaluations for their embedding models. So these are kind of the de facto standards of evaluating the word embedding models. Almost any language, new language that has been introduced, they have either translated or created a corresponding type of evaluations on top of the word embedding models. So what is analogy test? As you all might know, the analogy test is like it's a four element question, which is like A to A star is like B to B star, which we know that the famous version that is uh, king to man is queen to, and what we do is that we go and find the closest vector that satisfy the subtraction of these vectors, which uh, spits out the best fit for this. And these sort of analogy tests are grouped into some categories. For example, the capitals of the countries. I don't know, Cairo to Egypt is like Tehran to Iran or something like that. Similar categories go to the currencies and this sort of stuff. What we believe is that these sort of tests that have been devised uh, have very narrow, are capturing very narrow semantic relationships. What it means is that the capitals and currencies and very basic syntactic relationships are not going very deep into the structure of the language and deeper semantic relationships that can be made between the words in a language. So in what have been done for Persian type of analogy test, we can see that these are the relationships that have been used. For example, family relationships, currency relationships, I don't know, adjective, adverb, noun, adverb. These are antonyms, comparatives, superlatives. These sort of things are basically, for example, superlatives are like خوب بهترین or I'm sorry, I'm using some Persian words because what we are talking here is the Persian uh, part of the word embedding evaluation. Or singular plural would be something like dast ha, I don't know, کوچه ها, something like that, which is very simple type of relationship that we can observe inside the language. One thing that you might notice here is that the number of tests, number of here you can see the number of tests. Number of tests is actually to power of 2 because let's say if we have, I don't know, 20 pairs of relationship in each category. For sake of creating as much as test as possible, we can create n to power of 2, which is number of tuples that we can combine words in each category, which what you can see here is the huge number, but if you look at it, it's the like you have to count the square root of the actual pairs that have been used to create the data set. Okay, let's go. What we are proposing at this paper and what we have done is to look at more semantic oriented type of relationships between the language entities. Okay. The idea is inspired by GRE exam that we have seen, which is basically each question is something like the relationship between X and Y is like the relationship between a 5 choices of uh, word pairs. Now the question is how we are going to organize this and what sort of semantic relationships we are looking for to be used as baseline. So we are using, what we have done is that we found a similar work for English also by looking at the database of GRE tests that we have seen so far. What we have seen is what, as I said, it's based on the GRE history and also the English kind of the work that have been done. It's, if I'm not mistaken, it's around 67 categories that you can see here. And in each category, you can, the categories are in high level. They are divided into the class of relationship, semantic relationship taxonomy that you can see here. They start easily from the class inclusion. Then another category is the part whole. Then the class of similarity, contrast, attribute, non-attribute, case relationships, case purpose, space-time, and reference. Also, there are like several subclasses of each of them. For example, a class inclusion, the easiest one, maybe we say that is that one word or one entity is class inclusive of the other one. For example, emotion, the English example is going to be the emotion is a kind of, the rage, which is anger, is a kind of emotion. And we started to create our own version of the Persian ones. One thing that is very important to consider here is that simple translation of the words that already exist in English or other languages didn't work here. What we did is that we kind of gone to each subclass and started to think originally in Persian to build our data sets. So, for example, here, maybe the class inclusion is exception here, which is easier one. Maybe the translation will work here. For others, as we go, and I will give you more samples, are much harder to translate, and we have to think original in Persian language to get some examples of those class out. As you can see, the class inclusion could be taxonomic, could be functional, could be singular collective, and could be class individual. As you can see, it's very deep in terms of the different aspects of the taxon, relationships that you can think of. That sometimes we can see the outcome, what we have done in this paper. Also, we passed these tests to human as well and captured their response. So you will see that it is even for human, it's not an easy task to solve. As you can see, the class inclusion is one part. The different aspect is the part whole. For example, object component collection member. For example, I don't know, in English we have forest, and the tree is a member of a tree, the member of a forest. Here in Persian, the example that we have is that a qayiq is a part of a navgan. So you can see how deep relationships are getting captured here.